Lesson 107, Graphing Rational Functions, Part 2. So, when you're graphing rational functions, sometimes you have what's called slant or skew asymptotes. If there is a slant asymptote, there will be no horizontal asymptote. And vice versa. So if there is a horizontal asymptote, there will be no slant asymptote. There is a slant asymptote if the numerator has 1 degree more than the denominator. So 1 degree more than the denominator has. So you use polynomial division which I know you guys love to do. The quotient without the remainder. So you don't need to get the remainder. So you just find the quotient and then ignore the remainder. So the quotient without the remainder is the equation of the slant asymptote. So here's an example. Here's a function f of x equals x cubed plus 2x minus 4 divided by x squared minus 1. The numerator is of degree 3, the denominator is of degree 2. So because it's 1 more degree than the denominator, this will have a slant asymptote. So you have to use polynomial division and divide x cubed plus 2x minus 4 divided by x squared minus 1. We forgot to put in our x squared in here. I don't know if you guys remember, but you have to have a 0 x squared plus 2x minus 4. So x squared times x will give you the x cubed. So we'll put an x right here. Then we'll use the distributive property and we'll get x cubed minus x. We subtract, which means we change the signs, and we get x cubed minus x cubed goes to 0, 0x squared. Oops. Wait a minute, x cubed plus, oh, that's not going to work because this will just be, there'll be no x squared here, so we put our plus x over here. There we go. So, yeah, it was minus, we changed the sign, so that would be 3x minus 4. That's your remainder. So we ignore that, remember? So the equation y equals x is the slant asymptote. So you would just graph that line as a dotted line, and then you could graph the rest. Here's another example. F of x equals x to the 4th plus 2x cubed minus 5x squared minus 6x all over x cubed plus 2x squared minus x minus 2. Okay, one thing I want to do is simplify this before we do, instead of doing long division. So we could divide out an x out of all of this. So we have x to the 3rd plus 2x squared minus 5x minus 6. And then on this one, if we're going to factor by grouping. So here we can take out an x squared, and we're left with x plus 2. And here we can take out a negative 1, and we're left with x plus 2. So then when we factor this, we get x plus 2, x squared minus 1. X squared minus 1 is just x minus 1, x plus 1. So we could factor this top one, x cubed plus 2x squared minus 5x minus 6, is actually x plus 1, x plus 3, x minus 2. So we still have this x here. Now we can cancel. Let's see, we have a x plus 1, and we're left with x plus 3, x minus 2, divided by x plus 2, x minus 1. We know that x equals negative 1 is a whole because we canceled the x plus 1. So x plus 1 equals 0. So x equals negative 1 is a whole. So in your graph, anytime x, on the graph where x equals negative 1, you'll just draw a little hole. The vertical asymptotes are going to be where the denominator equals 0. So at negative 2 and 1.
Do you want me to have her call me back later?
Are vertical
No,
asymptotes. And that's because that's where the denominator is 0. To find the slant asymptote, we have to do long division here. So this is x cubed plus x squared minus 6x all over x squared plus x minus 2. So we're going to do long division here. So we want to find our slant asymptote. We're going to take x cubed plus x squared minus 6x, 3, 2, 1, divided by x squared plus x minus 2. X squared times x will give me x cubed. So we do x times x squared is x cubed, x times x is x squared, x times negative 2 is negative 2x. We subtract, change all the signs, and we get negative 4x. This is our remainder. We don't have to have that. Y equals x is our slant asymptote. And that's the end of lesson 107.